Good day, everyone. Today I'll be trying to solve permutation problems and probability problems. So the first question is, a printed circuit board has 8 different locations in which a component can be placed. If 4 different components are to be placed on the board, how many different designs are possible? So this is an example of a permutation problem. Permutation goes P n r, which also means n factorial over r factorial. In the problem, n is 8 locations, 8 different locations, and r is 4. So the permutation of n over r is equals to 8 factorial over r factorial. I mean 4. This is 4. The factorial is like this. You divide the number by the number less, you multiply, and so on until it reaches 1. So you can cancel this. This will be 8 times 7 times 6 times 5. So using a calculator, we can find the answer. 8 times 7 times 6 times 5. 1,680. So there are 1,680 different designs possible. So the next problem is, a part is labeled by printing with 4 thick lines, 3 medium lines, and 2 thin lines. If each ordering of the 9 lines represents a different label, how many different labels can be generated by using this scheme? To solve this, the formula we're going to use is n factorial over n1 factorial and 2 factorial, and so on, where n is the sum of n sub 1 plus n sub 2 plus n sub r. R is just the last number. So in the problem, n1 will be 4 because it means 4 thick lines. n2 will be 3 and n3 will be 2, where n is equals to 9, because 9, when you add this 4, 3 and 2, it will sum up to 9. So using the formula, 9 factorial over 4 factorial times 3 factorial times 2 factorial. This will be 9 times 8 times 7 times 6 times 5 times 4 factorial over 4 factorial, 3 factorial, and 2 factorial. You can cancel this, and 3 factorial is just 3 times 2, which is 6. You can cancel this, and 2 factorial is just 2, so we can cancel this with this. So we have 9 times 4 times 7 times 5. Again, using the calculator to find the answer. 9 times 4 times 7 times 5, and the answer is 1260. So there are about 1260 different labels that can be generated using the scheme. So next question. A jar containing 3 red marbles, 7 green marbles, and 10 white marbles. If a marble is drawn from the jar at random, what is the probability that this marble is white? So this is a probability problem. So in probability problems, you have probability of an event that will happen is equals to the favorable outcome, the favorable outcome all over to the total number of outcomes. Now this should be the number of favored outcomes. So the question, there are 3 red marbles, 7 green marbles, and 10 marbles, 10 white marbles. So we need to find the probability of the white marble drawn. This will become, so the number of favorable outcomes should be 10 because that's the number of the white marbles, over total number of outcomes. We just need to sum these numbers up, so this should be 20. So the probability of the white marble drawn at random is 0.5 or 50%. Next question. The blood groups of 200 people are distributed as follows. 50 have type A blood, 65 have B blood type, 70 have O blood type, and 15 have type AB. If a person is selected from this group at random, what is the probability that this person has an O blood type? So another probability problem. So the question, if a person is selected from the group at random, what is the probability that this person has O blood type? So the probability of an O blood type person to be picked is equals to the number of the O blood type people, which is, wait, let me write first the given, 50 blood type A, 65 blood type B, 70 blood type O, and 15 blood type AB. A total of 200 people. So the probability of a blood type O person to be picked at random in the group of 200 people is equals to 0.35 or or this will be 35%. So this means that if you pick a random person on the group of 200 people, so there is a 35% chance that that person will have a blood type O. Next question. A die is rolled. Find the probability that the number obtained is greater than 4. So another probability problem. A die, I'm just gonna write here, a die has 6 sides. Side 1, 2, 3, 4, 5, and 6. So numbers 5 and 6 are the only number greater than 4. So that means that the probability of a number that is greater than 4, I'm just going to write it as x, is equals to the number of the favorable outcome, which is 2, all over to the number of faces of a die, which is 6. So this will become 1/3, or 0.33, or 33%. So the probability that you roll a number greater than 4 is 33%. So let's proceed to the next problem. 2 coins are tossed. Find the probability that one head is only obtained. So 2 coins are tossed. So in this problem there are 4 different outcomes. So one outcome could be that the 2 coins could be heads and heads. The other could be heads and tails. Other could be tails and tails. And lastly, tails and heads. So these 4 are the possible outcomes when you toss 2 coins. But the problem asks for the probability that only one head is obtained. So the probability of only, let's just write x, one head obtained is equal to the number of favorable outcome, which is, there are 2. So this one head tails and this one tails heads. So there are 2 possible favorable outcomes over the total number of outcomes, which is 4. Forgot to write an equal sign. So the probability of one head is only obtained is equals to 0.5, or 50%. So when you toss 2 coins, there is a probability of 50% that you only obtain one head. Next question. 2 dice are rolled. Find the probability that the sum is equal to 5. 2 dice are rolled. Okay, so there are a possible of 6 sides times 6 sides is equals to 36. So there are a possible 36 number of total outcomes. And the question wants to find the probability that the sum is equal to 5. So numbers 1 and 4 that equals to 5, numbers 2 and 3 that equals to 5, numbers 3 and 2 that equals to 5, and 4 and 1 equals to 5. So the first column represents the first die. The second column represents the second die. So if you're asking why is it that these two numbers are not the same, that's because in this outcome, the first die is 1 and the second die is 4. And in this outcome, the first die is 4, the second die is 1. So there are there are only 4 possible outcomes, 4 favorable outcomes. So the probability that the sum is equal to 5 and 2 dice are rolled is equal to the number 4, which means the favorable outcome, number of the favorable outcome, over to the total outcomes, which is 36. So the probability is equals to, let me use the calculator, 4 over 36, 1 over 9, or 0.11, or 11%. So the probability that you roll, when you roll 2 dice and the probability of the sum is equal to 5 is 11%. Next question. A card is drawn at random from the deck of cards. Find the probability of getting the king of heart. So the total number in a card deck is 52. The total cards in the deck is 52, disregarding the jokers. And the number of king of hearts is only 1. King of hearts is only 1. So the probability of the king of hearts, of getting the king of hearts, is equals to the number of king of heart over the total number of cards in a deck. So this means, let me use the calculator again, 1 divided by 52 is equals to 0.019, or roughly it is 1.9%. So that's a small chance of getting a king of heart. Lastly, we have, I believe this is the last question. A die is rolled to find the probability that an even number is obtained. So the numbers in the die is 1, 2, 3, 4, 5, and 6. Even numbers are 2, 4, and 6. So the probability of getting an even number when you roll a die is equals to 3 over 6, because there are 3 even numbers and 6 total. 0.5 or 50%. That means you get 50% chance that you get an even number when you roll a die. So this is all the questions. Thank you for watching.